أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Hello students, this is Hafiz Muhammad Usama Ayub, and I am your new teacher of electricity and magnetism whose course code is PH105. You have already take the last three lectures of last week from Sir Tahir Jamal. Sir Tahir Jamal have given the lectures in last week, but from this week, I will continue this course of electricity and magnetism PH 105. Okay, because due to some reasons, the course teacher has been changed. So with the name of Allah, we will start this lecture. So first we will start the lectures. We will discuss about the recommended books, because I think recommended books also is important. Okay, so these are the recommended books. These 6 books are all the important books, and the last one, D. Halliday, R. Resnick and Crane Physics Volume 2 is the most important from your course point of view. Okay. The first book is Halliday, Resnick and Walker Fundamental of Physics. Second book is Survey and J.W. Jewett Physics for Scientists and Engineers. Third book is University Physics with Modern Physics. And fourth book is the Physics Classical and Modern, McGraw-Hill Publishers. Okay, and this book is also important, Physics for Scientists and Engineers, but I follow this last one book. Okay, I will follow this last one book, whose name is Physics Volume 2 by Halliday, Resnick and Crane. This is a famous book all over the world, and you have already used I think Volume 1 in the last semester, and in this semester we will use Volume 2, and we cover all course of electricity and magnetism from this book. All books are important. You can follow all these books. Okay, but I want to say that I will follow this book, Physics Volume 2. And one another important thing is that Halliday, Resnick and Walker and Halliday, Resnick and Crane, these two books are different. Okay, but if you say about the fundamental of physics, Halliday, Resnick and Walker, these two books are approximately same. Okay, these two books are approximately same, but if you go on the Google and you search Halliday, Resnick and Crane, so you will find Halliday, Resnick and Walker easily as compared to Halliday, Resnick and Crane Physics Volume 2, because the soft copy of Halliday, Resnick and Crane will not be easily available. Okay, is not easily available on the Google as compared to Halliday, Resnick and Crane. The University Physics is also an important book, so it's up to you as you wish. You can use any one book, or you can use Physics Volume 2. One another important thing is that volume Physics Halliday, Resnick and Crane by Halliday, Resnick and Crane has two volume 1 and volume 2. These are two different books. Volume 1 is other book and volume 2 is another book. Okay, so these are two different book as like your intermediate course. Okay, if you study in intermediate, if you think the two books of intermediate of first year and second year, so first year book of physics is different from second year physics. But if you see on the first year book, so you got chapter 1 to chapter 10, and in the second year book chapter 11 will be start, not chapter 1. Okay, because the second year physics is the volume 2 of first year physics. First year physics called as volume 1, first second year physics called as volume 2. Same thing is here. Okay, volume 1 is another book and volume 2 is another book. Volume 2 is the continuation of volume 1. So we will follow all over the course of electricity and magnetism from physics volume 2 by Halliday, and Coulomb, and as you wish you can study any one book. Okay, so go to the next. So after the discussion about the recommended books, we will remind that in the last lecture Sir Tahir Jamal have discussed few topics. Okay, so in last lectures we have already discussed about electric charge. Means in the last lecture Sir Tahir Jamal has also discussed about Sir Tahir Jamal also discussed about the sessional criteria. You have already known that 60% marks of your final exams and 40% marks of your sessional marks. Okay, so in the last lecture Sir Tahir Jamal has already discussed about the sessional criteria, that the 20% marks of your midterm, 10% marks of your assignment, and 10% marks of your quiz. Okay, so sir has already discussed about sessional marks, so there is no need to discuss about sessional marks criteria. And in the last lecture Sir Tahir Jamal also discussed about electric charge, and what is electric charge and what is the behavior of electric charge, and if we put one charge, if we put two charge, if we put three charge at a time, so what will happen. So Sir Tahir Jamal also discussed electric charge. The second topic is the properties of electric charge, means the behavior of electric charge, and if we put 2, 3, 4 or 5 charges or more than 5 charges placed at a time, so what will happen. So he already discussed properties of electric charge. Okay, conductor and its properties. What is conductor, what is the properties of conductor, what are the advantages, what are the disadvantages, and why we say that conductors, all things have already discussed in the last lecture from Sir Tahir Jamal. Insulators and its properties, it is also discussed in the last lecture. Okay, and now difference between conductors and insulator. In the last lecture, if you see in the last lecture, so it is also discussed about what's the difference between conductors and insulators. Okay, after the discussion about properties and characteristics of conductor and insulator, he will also discuss about difference between conductors and insulators. Continuous charge distribution is also an important topic, and he has also already discussed in the last lectures about continuous charge distribution. We have already know that there are three different types of charge distribution: surface charge distribution, linear charge distribution, and volume charge distribution, linear charge distribution and surface charge distribution. So we have already discussed about all three different charges distribution. Surface charge distribution, and the second is volume charge distribution and line charge distribution. Okay, so these are three different charge distributions. These are three different charge distributions: volume charge distribution, surface charge distribution, and line charge distribution. Okay, so all these topics which we have discussed, all these topics are discussed in the last lecture, and in the last lecture Sir Tahir Jamal has discussed about Coulomb's law. Okay, in last lecture Sir Tahir Jamal has discussed about Coulomb's law. So we will start again from Coulomb's law. We will not discuss all these topics which we have already discussed about here: electric charge, conductor, insulator, continuous charge distribution, difference between conductor and insulator. We will start from Coulomb's law. Okay, so now we will start from Coulomb's law. So our topic is Coulomb's law, and in this topic we will discuss about what is Coulomb's law, why we use this Coulomb's law. So we have all discussion, we have all discussed about Coulomb's law. Okay, so we shall consider the special case of electrostatic, in which all the source charges are stationary. Remind one thing, that if we discuss about term electrostatic, so it means that we have discussed about the electric charge which are in static condition or in stationary condition. If we discuss about electrostatic, so we have we will study about electric charge whose are in static or in stationary condition. So Coulomb's law is the basic law of electrostatic, and in the Coulomb's law we have discussed about the charges which are in stationary condition. Okay, so the principle of superposition states that the interaction between any two charges is completely unaffected by the presence of other. Okay, understand? The principle of superposition states that the interaction between any two charges is completely unaffected by the presence of other. It means that if you have two static charges, so they interact with only each other. Okay, they interact with each other. Okay, Coulomb's law, like Newton's law of gravitation, involves the concept of action at a distance. You have already you have all know about the Coulomb's law. That what is Coulomb's law? F is equals to k q1 q2 over r square. If I want to ask a question that what is Coulomb's law, so all of you say that Coulomb's law is F is equals to k q1 q2 over r square. Coulomb's force. Okay, what is Coulomb's force? A force which is directly proportional to the product of two charges and inversely proportional to the square of the distance between them. So there is a major part, or is a distance. Distance is a major part in this law. Okay. So Coulomb's law, like Newton's law of gravitation, involves the concept of action at a distance. Means if you increase the distance, Coulomb's law will be changed, and if you decrease the distance, Coulomb's law is also changed, like Newton's law of gravitation. Coulomb's law and Newton's law of gravitation, both law are same, means both law are like with each other. Okay, and in both laws, distance is main distance play a main role. Okay, distance play a main role. If you change the distance, the Coulomb's law or Newton's law will be changed. Okay, it simply states how the particle interacts but provide no explanation of the mechanism by which the force is transmitted from one point to the other. Even Newton himself is not comfortable with this aspect of his theory. Okay, this is an interesting thing. Newton himself is not comfortable with this aspect of his theory. Okay, so further move on the next slide. Here we will discuss more thing about Coulomb's law. Coulomb's law quantitatively describes the interaction of charges. In this last slide, we have already discussed that what is Coulomb's law. If I ask a question from you, what is Coulomb's law, you say that Coulomb's law is F is equals to K Q1 Q2 over R square. Means the product of two charges is directly proportional to the Coulomb's force and inversely proportional to the square of the distance between them. So Coulomb's law quantitatively describes the interaction of charges, means how the interaction of charges between them, means charges are near or far with each other, and what will its impact. Okay, so Coulomb's determined the force law for electrostatic charges directly by experiment. Okay, Coulomb's performed an experiment from which he determined the force law of electrostatic charges. Means he performed an experiment of two charges which is in stationary condition. We can say that electrostatic charges because these charges are in stationary condition. Okay, and experiments due to Coulomb and his contemporaries showed that the electrical force exerted by one charged body on another depends directly on the product of the magnitude of two charges and inversely on the square of their separation. Okay, this is the statement of Coulomb's law, and which I have already discussed in the last slide and in the beginning of this slide. What Coulomb's law, what is the description of Coulomb's law? Coulomb's law describes a force between two charges. Which force? That force is directly proportional to the square, directly proportional to the two charges. Okay, that force is the directly proportional to the product of two charges and inversely proportional to the square of distance between them, and this point is described the Coulomb's law. Experiments due to Coulomb and his contemporaries showed that the electrical force exerted by one charged body on another depends directly on the product of magnitudes of the two charges and inversely on the square of their separation. Okay, so further move. So what is Coulomb's law? We have already discussed F is equals to K Q1 Q2 over R square. Q1 is the small q, capital Q represents the Q2, means this is one charge and this is another charge, and R square, R is the distance between two charges. Okay, what is K? K is called as Coulomb's constant, which is equal to 1 over 4 pi epsilon naught. 1 over 4 pi epsilon naught. This is R is the position vector, which denote that this is a vector quantity. We all know that force is a vector quantity. We have a direction of resultant force. Okay, so this is a position vector, which denotes that we have a vector quantity. Okay, so we have Coulomb's force 1 over 4 pi epsilon naught q1 q2 over r square, and r is a position vector. So this is a figure. Okay, this is a figure. Two charges q1 and q2. We have two charges, and we discuss about what will impact on q1. This is a meter which shows the magnitude of force, that if we place a charge here, so what will its impact on the first charge, that is q1. Okay, so and this is the r is the distance between these two charges. Okay, so force is k q1 q2 over r square, where k is the 1 over 4 pi epsilon naught, and k is a Coulomb's constant, whose value is 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Okay, where epsilon naught is the permittivity of free space, and whose value, constant value, is 8.86 into 10 raised to the power minus 12 Coulomb square over Newton into meter square. Okay, so this is Coulomb's law, which we have discussed in last 2 slides or 3 slides, and in this slide. So this is the formula of Coulomb's force, and due with the help of this figure. Okay, so far we have considered only the magnitude of force between two charges determined according to Coulomb's law. Force, being a vector, has directional properties as well. Okay, as we discussed in the last slide, that force is a vector quantity, and force is a, so if a force is a vector quantity, so we have must a direction. Force has must a direction. Okay, so force, being a vector, has directional properties as well. In the case of Coulomb's law, the direction of force is determined by the relative sign of the two electric charges. Okay, if we discuss about electric charge in the last lecture, you have already discussed about electric charge and its properties. What you discussed, what you study in the last lecture? You study about if you have two plus sign, if you have two positive charges, so positive charges repel each other, and the negative one positive charge attract the negative charge, and if you have two positive charge, so the charges repel each other. Means like charges repel each other, and unlike charges attracts each other. Okay, if you have two negative charges, so both charges are also repel each other. So unlike charges attract each other. Okay, so force, being a vector, has directional property as well. In the case of Coulomb's law, the direction of force is determined by the relative sign of two electric charges. Okay, so now we will discuss Coulomb's law of vector form. Okay, so all we have discussed, all we have know that Coulomb's law is Coulomb's force has a vector quantity, so must that force has a any direction. Okay, so if you consider two charges, that q1 and q2, so you see on the figure you have two figures, figure A and figure B, and if you read the description of this figure, part A, about 2 point charges q1 and q2 of same sign exert equal and opposite repulsive forces on one another. Means that in part A you have two charges q1 and q2 of same sign. This sign could be can be positive, and this side can be sign can be negative. Okay, means same charges. So if you have two same charges like positive charges, these consider these two charges are positive charges. So what will happen? The vector r12 locates q1 relative to q2, and the unit vector r12 points in the direction of r12. Note that f12 is parallel to r12. Okay, so what will happen? Look here, q1, the force of q1 will exert on q2, but both signs are positive signs or negative sign, means both signs are same signs. So what will happen? If both signs are same sign, so both charges repel with each other, due to which force F21, the direction of F21 will be in this direction, and the direction of F12 will be in this direction. Okay, and this is the distance r12, this is another vector, and r12 is an position vector. Okay, so r12 will be in this direction. R12 means distance of 1 to 2, and F12 means the force exert from 1 to 2, means force exert from 1 to 2 and force exert from 2 to 1. So these signs are two different signs, two same sign, so both forces repel with each other, and F21 will be go in this direction, and F12 will be go in this direction. Now come on the part B, figure part B. So in part B, the two charges now have opposite sign. Opposite sign means unlike sign, and force is attractive. Means if we have two charges of unlike signs, means consider one charge is positive and second charge is negative, so these both charges attract with each other and the force is attractive. And note that F12 is anti-parallel to R12. So in the part B, these both charges are Q1 and Q2. These both charges are F12 will be attract from Q2, and Q2 will be attract on Q1. So the direction of F12 will be on Q2, and the direction of F21 will be on Q1, unlike part A. In the part A, the direction of F12 on the left side, but in part B, the direction of F12 on the right side, and same with Q2 and the direction of F21. Okay, so if we take two different charges, or two same charges, the behavior of charges will quite different. Okay, the behavior of charges will quite different, and due to the behavior of charges, the vector force, the position vector or the force vector will also be different. So the Coulomb's law, the vector of Coulomb's force will also be different due to the changes of charges. Okay, if you take two same charges, the force will be different, and if we take two different charges, so the force will be different from the uh, other condition. Okay, so the sign of the charges will be considered. Okay, so go on the next slide. So F12, we have discussed about F12 and F21. So F12 will be equal to 1 over 4 pi epsilon Q1 Q2 over R square. Means what is the force of F12? Force of F12 is this force, and is this force that Q1 will be exert on the Q2, the force which exert on the second charge. And what will F21? Guess, any guess? What is the formula of F21? This is the formula of F21. Okay, this is the formula of F21. 1 over 4 pi epsilon naught Q1 Q2 over R square R21 in place of R12. So these are two different forces. Okay, these are two different forces if we discuss in vector condition. If we discuss in vector form, these are two different forces, not same forces. Okay, because these vectors are different. Okay, so the vectors are different, so the direction is also different. Okay, maybe possible the magnitude can be same, but the direction is different, so the force will also be different, because force is a vector quantity. Okay, so in the last we have discussed this numerical. In the last of this lecture, in the end of this lecture, we have discussed this numerical. This is the sample problem number 1 of your book, and figure 6 show. Where is figure 6? This is the figure 6. This is the figure 6. This is figure 6. Okay, so figure 6 shows, read this numerical. Figure 6 shows 3 charged particles held in place, forces not shown. Okay, so this is the figure 6. 3 charges placed in this configuration, means Q1 is placed on the origin, and Q2 is placed on the same direction but in positive x direction, and Q3 is placed in this direction. This is y axis and this is x axis. Okay, this is positive charge, or negative charge is on the origin, and in this direction this is here is a negative charge. Okay, so question is that what electric force owing to other two charges act on Q1? Takes Q1 is equals to minus 1.2 microcoulomb, Q2 is equal to 3.7 microcoulomb, Q3 is equal to minus 2.3 microcoulomb, R12 is equals to 15 centimeter, R13 is equals to 10 centimeter, and theta is equals to 32 degree. So question किया गया है, question is that what electrostatic forces owing the two other two charges act on Q1. means if a charge placed on q1, so what electrostatic force will be exerted on q1 from q3, and what electrostatic charge force will exert on q1 from q2. Okay, so this is a sample problem, so solution is also here. This is the solution of your question. I think we have not much more time for solving uh, in detail or solving in deep, because if we solve this in detail, so the time will be cross. Okay, because we have a limited time. So I think all the students have already seen the solution of this the solution of this numerical. So because we will solve this numerical in vector form, and we will solve this numerical due to this figure. So solve this by own, and we will discuss this problem in the last lecture. Sorry, last lecture, not in last lecture. We will discuss this numerical in the next lecture. Okay, in detail. You have already seen the solution of this numerical, so solve yourself, and if you have any problem in the solution of this numerical, so we will discuss in the next lecture. Okay, so Allah Hafiz, and meet you in the we will meet you in the next lecture. Thank you.